Today we're going to be converting rational numbers, or you might call them decimals, to fractions. So the first thing we're going to look at is simply how to write a whole number as a fraction. 13 means that you have 13 wholes. That means each whole is divided into one group. So you simply put a whole number over 1 to write it as a fraction. When you have an improper fraction, or a mixed number, and you want to write it as an improper fraction, I want to show you this model to help you know why we have the rule that we do. We have -2. These two wholes are represented by these two circles that are completely shaded. And 2/3, the 2/3 is represented right here by the two shaded 3 parts. Notice that each of the wholes are divided into thirds. So if we were to count all of the thirds that were present here, 1, 2, 3, 4, 5, 6, 7, 8, you would see that there are 8 of them, and each whole is divided into thirds. That's where we get the 3, and of course it's negative. So if you look at the illustration, you can see that. Now you probably have heard of the rule that to figure this out, you take the denominator and multiply it times the whole number. That's 3 times 2, because there's 3 parts and there's 2 wholes. So the 3 times 2 gives you how many are shaded right here within the 2 wholes, which is 6. Then you add the numerator, which is adding these 2 parts over here, and that gives you the 8. So the basic rule is, and the illustration I hope to help show you why this is true, you multiply the 3 times the 2, that gives us the 6, plus 2, which gives us the 8. We know it was negative and that it was divided into thirds. Look at another illustration. Here we have -1 and 5/6. This represents the one whole divided into 6 parts, and here are 5 of 6 parts shaded. So how many are shaded altogether? Well, here's 6 over in the whole. 7, 8, 9, 10, 11. There are 11. So what do we have to do? 1 times 6 is 6. That tells us how many are right here. Plus we add the additional 5 that are over here, and that gives us our 11. And each is divided into 6, so we keep the denominator. So it's a -11/6. Now, in order to convert decimals to fractions, as long as you are reading decimals correctly, they read exactly like a fraction. So let's review real quickly. In decimals, the first place value is tenths, the second place value is hundredths, the third place value is thousandths. So when reading this, we read the number 375, and then you say the place value of the last digit. Since that is in the thousandths place, we read that 375 thousandths. Now the fraction is going to read just like that. So how do you write a fraction as 375 thousandths? You put 375 divided by 1,000. Reads exactly the same. Now both of these numbers happen to be divisible by 125. So when we simplify it, it simplifies down to 3/8. Here we have a one number in the decimal, so this is in the tenths column. So we say this is 4/10, and because of the negative sign, it is a -4/10. So the fraction is going to read exactly like that, -4/10. So you put the 4 over 10. Both of those numbers are divisible by 2. So when we simplify it, we're still going to have the negative sign, and it's going to be -2/5. Here we have a number in front of the decimal, so we read this 7, and then we say and for the decimal. Then we read the 3, and this is in the hundredths column, so we say 7 and 3/100ths. 7 and 3/100ths. So when we write that, it's going to be a mixed number, 7 and 3 over 100. It reads the same way though, 7 and 3/100ths. And that one cannot be simplified. Here we have 2 digits in the decimal. This last one is in the hundredths place, so we say 16/100ths. So when we write the fraction for that, it is 16 over 100, or you read it 16/100ths. Both of those numbers are divisible by 4, so when you simplify it, it would become 4/25. Here's one that reads 2 and 8 tenths. 2 and 8 tenths. So we can write that as a mixed number, 2 and 8 tenths. Both the 8 and the 10 are divisible by 2. So when we simplify it, it becomes 2 and 4 fifths. There's some special decimals that we need to make special note of. Now, when you see a decimal written 0.1, we have been taught to read this as 1/10, which it is 1/10. But if there is a repeat line over the top, look right here, this is telling you that this decimal would be 0.11111 repeating on and on and on forever. So that is not 1/10, because the decimal 1/10 would be a 1 in the tenths place with zeros after it. But since this one is like this, it is not 1/10, it is 1/9. If there is one number in the decimal, in the tenths column, and it has a repeat line over it, it's going to be ninths and not tenths. Because if you take 1 and you divide it by 9, you are going to get, I'm trying to do this real fast. You're going to get this loop, and you're going to keep, bring down a 0. Oops, I already brought down that 0. 9 minus 1, 0. You're going to get this repeating decimal up here of 1, 1, 1, 1, 1, 1, 1. Important thing to note, if there is a repeating line over it, do not read it as 1/10. You read it as 1/9. I kind of rambled there for a minute, but it's okay. Again, we have a single digit. This would read 2/10 without the repeating line on top, but because of the repeating line on top, it is not 2/10, it is 2/9. Same thing with the next one would be 3/9, but it can be simplified to 1/3. 4/9, not 5/10, but 5/9. 6/9 can be simplified to 2/3. 7/9, 8/9, and 9/9 can be simplified to 1/2. This is very important that you know the difference between 5/10 and 5/9. So watch for the repeat line, which changes the denominator to ninths. Some other special decimals that you might want to take note of are the ones with 3 decimals that are in the thousands column. Here, if you look at the numbers in the decimal, we're actually counting by 125s. Each time it goes up by 125. When you do this, this is creating the decimals, or the fractions, I'm sorry, with 8 as a denominator. The first one reads as 125 thousandths. Both of those numbers are divisible by 125, and when you divide by 125, you get 1/8. On the next one, it reads as 251 thousandths. Both of those are divisible by 125, and when you do that, you get 2/8, which simplifies to 1/4. That pattern continues. This next one reads 375 thousandths. 375 and 1,000 are divisible by 125 again, because we're counting by 125s, and simplifies to 3/8. So it continues on. This would be 4/8, or simplified into 1/2. This would be counting by 125 5 times, so that's 5/8. Counting by 125 6 times gives you 750, or simplifies to 3/4. And 875 thousandths becomes 7/8. So when you see 3 digits, see if the digits are a number that's when you count by 125s. If it is, you know it's going to be a fraction with the eighths. This would do you well to memorize these, or get familiar with counting by 125, so that these can be something you can memorize. Now, going back to what we talked about previously, you see this decimal right here, but you see the repeat line. So this decimal is not 6/10. That decimal is 6/9. So we read this as -5 and 6/9. 6/9 can be reduced by dividing both of those numbers by 3 to -5 and 2/3. It works the same way with 2 digits. If you have 2 digits in the decimal and there's a repeat line over both of them, that means that this decimal would keep repeating like this over and over and over again. So instead of tenths, because instead of this being 23 hundredths, that would be a decimal that is 6.23 with zeros after it. But because the 2 and the 3 repeat over and over again, it is 90/9. 2 digits, 2 nines, 90/9. So this decimal does not read 6 and 23 hundredths. It reads 6 and 23 90/9. You could actually do the same thing. I'm going to say that for a different lesson. You can actually do the same thing with 3 digits if you have, or 4 digits and so forth. If you have some numbers in the decimal, like 3 digits, and all 3 of them repeat, that means it would be 514, 514, 514, and so forth. You don't read that as thousandths, you read it as 999ths. So this decimal would be 7 and 514 999ths, not 1,000ths. Kind of an interesting thing about numbers. I hope this helps.